Hello, welcome everyone. This is Ahmed Mahmoud, the head of data engineering at DataMind AI. So, data teams are under more pressure than ever before. Pipelines are growing in complexity, and the compliance demands are tightening, and the expectation that data is always accurate, always available, always trusted has never been higher. Yet, in many organizations, deploying a database change still involves a manual SQL scripts, shared service accounts, and a single engineer who holds the institutional knowledge of how things are supposed to work. Now, that is not a data problem, that is an engineering culture problem. And today, we are going to fix it with CI/CD built natively inside Snowflake. Now, CI/CD stands for continuous integration and continuous delivery. It is a set of practice originally born in software engineering that fundamentally changes how code moves from a developer's laptop into production. The CI side of it is a continuous integration, and every change a team member makes is automatically tested, validated, and merged into a shared code base. No more integration nightmares at release time. No more, it worked on my machine. The other side is the CD side, is a continuous delivery. Now, those validated changes are packed and deployed automatically through a defined sequence of environments. So every deployment is consistent, every deployment is traceable. So every deployment can also be reversed. Now, for application developers, this has been standard practice for over a decade. But for data engineering, for SQL, for schema management, for warehouse configuration, the tooling has historically lagged behind until now, that is. Now, Snowflake has invested heavily in closing that gap. So, with native Git integration, environment based architecture, and first class support for version control data workflows, we have everything we need to run a production grade CI CD pipeline entirely inside the Snowflake ecosystem. Now, to understand why Snowflake is uniquely positioned for CI CD, we need to briefly revisit what makes Snowflake different as a platform. So, Snowflake's architecture separates the storage, compute, and services into independent layers. So this is critically important for CI/CD because it means we can spin up isolated virtual warehouse for each environment. So for dev, for UAT, and prod. So without duplicating data or incurring unnecessary cost. Now, Snowflake objects like databases, schemas, tables, views, tasks, pipes, streams are all first class citizens of the platform. They can be defined in SQL, they can be version controlled, and they can be deployed programmatically. Now, and with the Snowflake Workspace, which is the modern workspace, the modern one, the modern IDE like development environment built into Snowflake, developers now have a purpose built space to write, test, and iterate on their code before it ever leaves their hands. Now, Workspace brings your version controlled files directly into the Snowflake interface. You can open a notebook, write a stored procedure, modify schema definition, and all of it is connected to your Git repository in real time. That uh, feedback loop between writing code, running it in the context, and committing it into source control is what makes Snowflake approach to CI/CD feel native rather than a bolted one. At the heart of everything we are going to build today is Snowflake's Git integration. So this is a feature that allows Snowflake to directly connect to a Git repository, whether that is GitHub, GitLab, Azure DevOps, or Bitbuckets, and treat that repository as a versioned stage inside the platform. So what does that mean in practice? It means your SQL script, your Jinja templates, your stores procedures, your data quality test, all of your data assets live in Git. They are subjected to code review. They have a full audit trail. They can be branched, tagged, and rollback. Now, when you configure a Git repository in Snowflake, you create what is called a Git repository stage. This stage is a live mirror of your repository. Snowflake can reference files directly from it. For example, you can execute immediate from a file or call a procedure defined in a version control script. Now, the configuration itself is straightforward. You create an API integration that defines the trust relationship between Snowflake and the Git provider. You then create a secret object that securely stores your credentials, a personal access token, or preferably a service account token. And finally, you create the Git repository object itself. We are going to look at it on the demo. Now, what is powerful about Snowflake's new integration with the workspace is that this is not just a deployment mechanism; it is a living development environment. Now, when you open a file in Workspace that's linked to Git repository, you are editing a version controlled asset. When you run it, you are running it in context, yeah? And when you commit, that commit triggers your CI/CD pipeline downstream. That is a full developer's loop inside a single platform. Now, one of the most important mindset shift in applying DevOps principles to Snowflake is this: everything is an object, and every object can be defined as code. So your database or your schemas, your virtual warehouse, their size, their auto-suspense settings, their multiple cluster configuration, your roles, your access grants, your tasks, streams, pipes, and dynamic tables, every single one of these can be expressed in SQL and stored in your Git repository. Now, this is what we mean by infrastructure as a code. For the data platform, when a new developer joins the team, they don't need someone to hand configure their environment. They run the script, the environment builds itself. When you need to promote a change from dev to UAT, you don't copy files manually. The pipeline runs the same script against UAT schema using UAT credentials with the UAT configuration injected through the secrets. And critically, when something goes wrong in production, you can roll back because the production state is simply the result of running a known set of version script. The database is reproducible, and that reproducibility is what makes on call a much less frightening word. Now, connecting your repository to Snowflake is one thing, but managing how schema changes evolve over time across environments, across releases, across teams requires a disciplined approach to database migration. This is where Schemachange comes in. Schemachange is an open source, lightweight database change management tool built specifically for Snowflake. It was inspired by Flyware, a popular tool in the Java ecosystem, but designed from the ground up with Snowflake architecture and SQL dialect in mind. The core concept is simple. Every change in your database schema is captured in a migration script, a SQL file with a version number embedded in its name. So Schemachange tracks which script have already been applied to an environment and applies only the new ones in order. So this means your migration history is your schema history. If you want to know what your production database looked like 6 months ago, you look at the migration scripts that existed at that point in time. Your schema evolves in lockstep with your code base. Now, Schemachange supports both version script for permanent sequential changes and repeatable scripts for objects like views, stored procedure, and tasks that should be recreated in full whenever they change. The tool integrates cleanly in GitHub Actions. You add a single step in your workflow, run Schemachange, and pass it your Snowflake credentials, your target environment, and the path to your migration script. Schemachange handles the rest. Now, what Schemachange added to Snowflake ecosystem was not just migration management, it added discipline as well. It added the expectation that schema changes are deliberate, reviewed, versioned, and applied consistently. It made database as a code a practical reality rather than an inspiration. Now, let us bring this all together and look at what a complete Snowflake CI/CD architecture look like. So, a developer writes SQL or Python in Snowflake Workspace. Yeah, so you are a developer, you are writing SQL or Python in Snowflake Workspace, connected live to a featured branch in GitHub. They test their changes against the dev environment using dedicated virtual warehouse, a dedicated schema, and a dedicated role with the minimum permission required. Now, when they are satisfied, they open a pull request. So the pull request triggers an automated CI workflow in GitHub Actions. So the workflow runs data quality checks, linting, and automated tests against the dev environment. If everything passes, then the PR is eligible for review. A peer review the codes, they approve, the branch is merged to the UAT branch. A second workflow triggers. This one deploying to UAT environment, running integration tests, and optionally posing for a human approval get before production. Once approved, the final deployment to prod runs Schemachange applies only the new migration scripts. The workflow completes the Snowflake audit logs recorded who ran what and when. Now, now for data engineering, CI/CD unlocks a fundamentally different way of working. Now, transformation logic, whether written in raw SQL or dbt or Snowflake native dynamic tables, can be tested before it ever reaches a production data. Unit tests validate logic. Integration tests validate data quality. Schema contracts ensure that upstream changes don't silently break downstream consumers. Now, for database administrators and platform engineers, CI/CD brings governance to a layer of the stack that has historically been managed through ad hoc scripting and tribal knowledge. Now, role definitions, data access grants, and network policies, resource monitors, all of these can live in version control. Onboarding a new environment is a pipeline run, not a weekend of a manual work. And for organization as a whole, CI/CD on Snowflake means data changes are no longer invisible. Every modification to the platform, every new table, and every schema alteration, every role grant is traceable to pull request, a developer, and a business requirements. That traceability is not just good engineering, and in regulated industry, it is a compliance requirement. Now, we are at an inflection point in data engineering. The tools are mature, the patterns are established, the industry has aligned around Git at the source of truth, CI/CD as a deployment mechanism, and cloud-native platform like Snowflake at the execution environment. So what is changing now is the depth of integration. Snowflake is not simply a destination for your data anymore. It is an active participant in the development lifecycle. Workspace, Git integration, native testing framework, and Snowflake all point in the same direction. Snowflake wants to be the place where data engineers do their best work, from first line of code to production deployment. Now, Schemachange will continue to evolve. The community around it is active, and its patterns are being adapted by data teams across industries, from financial services to healthcare, from logistics to government. So, in this workshop, we are going to build this architecture from the ground up. We will configure Snowflake, connect it to GitHub, set up isolated environments, secure our service accounts with key pair authentication, and deploy a real CI/CD pipeline for NHS accident and emergency data. That data, of course, is like dummy data, but we are going to use that kind of environment, NHS and accident emergency data. By the end of today, you won't just understand CI/CD in the Snowflake conceptually, you will have built it, and you will be able to take that foundation and apply it to any data platform challenge your organization faces. So let us begin.